So for this picture, we are asked to solve for d and then find the measure of theta. So we have to make sure we do both of those items. Solve for d and then also find the measure of theta. So we're given this diagram. Now we do see these arrows here and these matching arrows here. So that does mean that we do have two sets of parallel lines. So we have this pink set of parallel lines cut by this transversal, and also cut by the transversal down there. So let's start working with this set right here. So we're given both of these pieces. Now if we look at this angle and this angle, what kind of relationship do they have? Now they are basically on one pizza, correct? So they are all on one pizza. Here's the middle of the pizza. So these two are literally make up a half of a pizza. So this is one side of a pizza. Now my pizza is quite crooked, but it is a half a pizza. So we do know that a half a pizza, we're going to have the relationship that these are going to be supplementary. So this half a pizza is going to add up to be 180. So we do know this angle measure plus this angle measure does have to equal 180. So let's go ahead and set up an equation. So we have a 4, and we have 2d minus 4 plus that 8d together have to add up to be 180 degrees because they do make a half a pizza. So I'm going to go ahead and do my algebra. I need to distribute because I have some parentheses. So 4 times 2d gives me 8d minus 4 times 4 gives me 16 plus 8d is equal to 180. Oh my gosh, I hate when it does that. Okay, so on the same side of my equation, I do have some like terms. So 8d and 8d make 16d. And then I have that minus 16 is equal to 180. So I'm going to try to get d by itself by adding 16 on both sides. So I get 16d is equal to, what is 180? Check out your calculator. 180 plus 16 is 196. And then I have to divide both sides by 16. So I have 196 divided by 16. And that gives me 12.25. So d is equal to 12.25. Okay, so I'm going to go back to my picture. I'm going to erase some of this so that I can actually do some work. So I'm going to be plugging in to find the measure of some angles. So I do have d. That was one item we had to find. And now I need to plug d in to get some measures of the angles. This is 12.25, and this one here is going to be 12.25. So that means I need to plug in, like, for example, 8 times 12.25. So I get the measure of this angle here to be 98 degrees. So this is 98 degrees. Now remember, I do have lots of sets of parallel lines. So if this is 98 degrees, the vertical angle across from it is 98 degrees. Could even jump down here. This angle and this angle are corresponding angles, so I can also write down 98 degrees here. I probably don't even need to do this work over here. So this is going to allow me to jump over to here, because if I turn my head sideways, I have from here to here, since I have this green set of parallel lines cut by this transversal, these two are also corresponding. So I have a 98 here. And I can get this theta that I need because this is a half a circle, right? And so half a circle has to be 180. So I could just do some number. I could just do 180 minus 98, and that gives me 82 degrees right here. Now, there are other ways you could have done this problem. I could have plugged in the 12.25 here. So if I plug that in there, I would get 2 times 12.25, and then minus 4, and then that whole thing times this 4 on the outside. So I would get that this angle up here to be 82 degrees. Now I could have gotten this 82, and that could have gotten me over to here, and this would be 82 by corresponding angles. And then you see that this 82 and this theta, the 82 right here, and this theta are alternate exterior angles, so they are congruent to each other. So I could have gotten 82 here and gotten to this 82. There are many ways to get to the all of the angles in this picture. So it says, can you find the measure of every angle in the diagram? You sure can, because when we have these angles cut by transversals, I'm going to go ahead and label all of the ones that are yellow. This one is going to be congruent to this one. Oh,